This session is about block diagrams, its constituents and various topologies. Let us start with a simple RC circuit whose transfer function can be obtained using the following steps. First, we model the RC circuit using Kirchhoff's voltage law. We write equations for V1 and V2. Then we take the Laplace transform of the equations and we get V1 of S and V2 of S. As per the transfer function definition, it is the ratio of Laplace transform of the output to the Laplace transform of the input. So we take ratio V2 of S by V1 of S. And finally we end up with the result 1 by RC divided by S plus 1 by RC. If I try to write this transfer function as a block diagram, I can use this diagram. That is, it has a single block whose transfer function is 1 by RC by S plus 1 by RC with an input signal V1 of S and an output signal V2 of S. If I give some numerical value, then it can be written like 20 by S plus 20. So 1 by RC is equal to 20. In any transfer function, the numerical values actually depicts some key elements in the system. A simple block diagram representation is given here. It has an input R of S, a transfer function G of S and an output C of S. The transfer function is G of S is equal to C of S by R of S. It gives the input-output relation. The various constituents of a block diagram are blocks, summing junctions and pick-off points. Let us discuss the various parts in detail. Here we have a summing junction. A summing junction is nothing but a junction where signals meet. I can write P of S as R1 of S minus R2 of S. When we write the output of the summing junction, the sign of the summing junction is to be considered. Next we have a pick-off point. A pick-off point is one in which the signal is taken so that a new parallel path can be formed. So in this case, this represents a pick-off point, which means the signal R of S is divided into three parts. Each path represents a signal R of S. These are some of the common topologies in block diagrams. The first one is the cascade form. In cascade form, the various blocks are connected in succession. So, we need to just multiply the transfer functions of each blocks. Here you can see that the signal at this point would be R of S multiplied by G1 of S. The signal at this point would be R of S into G1 of S multiplied by G2 of S. And the final signal at this point would be R of S, G1 of S, G2 of S into G3 of S. So we can say that C of S is equal to the signal. So in a single block diagram, I can represent it as G1 of S into G2 of S into G3 of S. Because C of S by R of S would be G1 of S into G2 of S into G3 of S. When we do cascading, we should be very careful about the loading effect. This can be explained by taking a simple example like this. Let us have two RC circuits whose transfer functions are given by G1 and G2. So if these two circuits are connected in cascade, the effective transfer function V2 by Vi would be G1 into G2, which is obtained by this one. But if you find the transfer function of this circuit using the loop equation or the mesh equation or the node equation, the total transfer function is obtained like this. We can see that these two transfer functions are not same. This is because there is a loading effect of this section over the first part. It means that when this second section is connected to the first, it takes some current from the first. This can be avoided by placing an amplifier like this, which has a very high input impedance. When the input impedance of this amplifier is very high, the second section will not be acting as a load to the first. The second is the parallel form. Here, various blocks are connected in parallel so that effective transfer function is just the sum or the difference between the various parts. So here we can say C of S and R of S will be connected using the block plus or minus G1 of S, plus or minus G2 of S, plus or minus G3 of S. The third is the feedback form. The output signal is taken and then it is connected to a summing junction at the input side. Hence we have a feedback. The transfer function C of S by R of S can be obtained as follows. We can write the equations C of S equal to E of S into G of S, and E of S is R of S minus C of S into H of S. Substitute the second in the first. So we have C of S is equal to R of S minus C of S into H of S, the whole into G of S. That is equal to G of S into R of S minus C of S into G of S into H of S. Taking C of S terms together, C of S into 1 plus G of S into H of S equal to G of S into R of S. So C of S by R of S is equal to G of S divided by 1 plus GSHS. Here we can see that we have a negative feedback. So the negative feedback results in a transfer function like this. If we have a positive feedback, the transfer function would be G of S divided by 1 minus GS into HS. Thank you.